Hello everybody, and welcome to exercise E this is page 36 of the workbook that we're looking at. And the instructions of this problem are actually on the previous page. It's asking us to find the volume of the solid that we get if we rotate the region R3 about the line y equals 3. Okay, and we're going to need to scroll up just to kind of see what this region is that they're talking about. Okay, so R3 is this region that I'm kind of tracing out here. We'd like to take that and rotate it about the line y equals 3. Okay, so let's draw a picture down below here. Okay, so R3 kind of have the shape of a triangle. And where is the line y equals 3 in this picture? Well, I kind of need to sneak a peek up above again. Okay, notice that y equals 2 is kind of the top part of the region, so y equals 3 is sitting up here a little bit higher. So our axis of rotation is actually kind of up here in this case, y equals 3. So imagine taking this triangle and just flipping it straight through that line. So this point's going to come out here. We're thinking of the line y equals 3 as kind of being like a big mirror. Okay, and that point's going to come out an equal distance above, and if we draw the mirror image, okay, it's going to kind of look like this. Okay, so we are ready to take out that machete and slice this region, and I'm going to remind you again, we want to slice perpendicular to the axis of rotation. Perpendicular to y equals 3 means that we're going to be slicing top to bottom in this case. Okay, so if we take a big slice of this, what do you think? Are we going to get a solid region, or are we going to get a solid slice or a slice with a hole in the middle? Okay, I'm kind of seeing a gap here. So what we should get is a washer-shaped slice in this case. Okay, and then comes the important question that we've asked several times. What kinds of radii are we going to get for this slice? What do you see? Do you see horizontal or vertical radii? Okay, I am seeing vertical radii in this. So for example, the smaller of the two radii would be from here to here. The fact that it's vertical is important because it tells us that what we need to know is what y is equal to. Oh, and actually, let me back up for just a second here. I'm kind of doing my drawing on the mirror image. I'd prefer to do the drawing down here where the actual curve is. Okay, so let's erase that. Okay, and the reason why that's important is we need to be able to pick out what the equation of our curve is somehow. Okay, so I'm going to draw the radius like this because now we're actually touching one of our curves when we do it. Okay, and we want to know what y is equal to there and there. Okay, well, you can probably tell me what the y value is up here at the top. We can see from our picture already that that's y equals 3. Okay, the more interesting question is what's y equal to down here at the bottom? Okay, well, to answer that, we need to know what curve it is that we're looking at right there. Okay, so let's scroll down and see. In our picture that they gave us, they told us that that line is x equals 4y. Okay, so we want to know what y is equal to on that line. So how would we solve for y in that equation? Well, we could just take it and divide both sides by 4, and we're going to get y equals x over 4 for that point. Okay, and then to find the bigger radius, we're going to be interested in knowing what the y value is equal to down at that bottom point. Let's go up to our picture and see if we can figure that out. Okay, so the bottom of the triangle is right here, and notice that that's right on the x-axis. That's y equals 0 in our picture. Okay, so we are ready then to draw kind of a front view of our slice. And to just draw in the radii. Okay, so here's our washer. And we'll start with the with the inner radius, the smaller one, that's this distance from here to here. It's vertical, so we need to subtract the y values, 3 minus x over 4. Okay, what about the bigger radius? Well, that would be the distance all the way from here down to there. So if you subtract those two y values, we're going to take 3 minus 0 and get a radius of just 3 for that. Okay, and so the volume then should be the integral of the area of that washer. So we're going to take pi times the bigger radius squared minus pi times the smaller radius squared. Okay, and then what's left is the limits of integration. Are they going to be x or y values? Well, they're going to have to be x values because x is the variable in our integral. And so where do we start and where do we stop slicing? Let's take a peek. Okay, you can see from the picture that we start over here at x equals 0 and we stop here at x equals 8. And so that tells us what our limits of integration should be. Okay, and that looks like a final answer.